Hi guys, do you know that every day we at least consume 12% toxic chemical from pesticide in our food? This toxic chemical come from pesticide that used to protect crops from insect, weeds and infection. Pesticides are widely used to maximize agriculture yield. However, their full effect on human health and environment in which they are used are still under investigation. Therefore, pesticide analysis is becoming increasingly important as consumers become more aware of what it is in their food. Thus, to establish the safety of our food, toxic and harmful chemicals in food must be measured before consumption. So, scientists come up with chromatography technique used to analyze pesticide and their residue phase when there is consistency in retention time. Moreover, when detecting pesticide in food, several chromatographic techniques are commonly used. For example, thin layer chromatography (TLC), gas liquid chromatography (GLC), liquid chromatography mass spectrometry (LCMS).
Hi, my name is Muhammad Farhan. Alright, now I will explain about the theory of application for TLC. First, we have basic principle, which is the first one is stationary phase. Stationary phase is a thin layer of adsorbent material. The second one is mobile phase. Mobile phase is a solvent or mixture of solvent that move through the stationary phase by capillary action. And the last one, we have separation mechanism. What is separation mechanism? Separation mechanism is a compound in the mixture interact differently with the stationary and mobile phase based on their polarity. For example, if it has higher polarity, so the stationary phase is stronger than mobile phase. But if the polarity is weak, the stationary phase is lower than mobile phase. And now we go with the second one, which is a process. Okay, process, it also has three, which is preparation. Preparation is a small part of the sample mixture is applied near the bottom of the TLC plate. The second one is development, and the last one is detection. If you guys want to know more about this process, you guys can wait for the second slide. Okay, and the last one we go with retention factor, which is RF. The RF value is a characteristic for each compound under specific condition and can be used for identification. For the example, highest RF value shown which elite first, but we should beware with reverse and forward TLC. If reverse TLC, the highest one is the last elite, but if forward TLC, it's like a normal, highest RF value, elite first.
Okay, for methodology, we have 6 steps. First, preparation sample. We have to blend the food sample to ensure a homogeneous mixture with a suitable solvent to extract pesticide from the sample, ensure the solvent is compatible with TLC and can dissolve the pesticide effectively. And then filter the extracted solution to remove any solid particles that could interfere with TLC analysis. Okay, next we have preparation of TLC plates. TLC plates were selected with appropriate characteristic. Use a pencil to mark the origin line on the TLC plate. This line indicates where the sample will be applied, and then tip the TLC plates by heating in the oven or using a blow dryer to remove any moisture and improve separation. Okay, next we have application of sample. Apply a small amount of the prepared sample solution onto the marked origin line using a micropipette or capillary tube. This allows the spot to dry completely between applications of multiple samples to be analyzed. And then we have development of TLC plates. Place the TLC plate in the developing chamber filled with appropriate solvent mixture, or we call it as mobile phase. The choice of solvent depends on the quality of the pesticide being analyzed. Then close the chamber to allow the solvent to ascend the plate by capillary action. Ensure the solvent front does not reach the top of the plate, prevent the loss of resolution. And then for the last two, we have visualization of separated compounds. Remove the TLC plates from the chamber and allow it to dry completely. Visualize the separated spots under UV light or using a suitable visualization agent specific to pesticide. Okay, lastly we have analysis and interpretation. measure the distance traveled by the solvent plant and each spot, and then compare the RF value of the spot with those of known pesticide standards analyzed under the same conditions.
So for this part, I'm going to give an example of the result we can obtain from the experiment of TLC in detecting the pesticides in food samples. The 4 food samples used are apple, tomato, spinach and rice. And the pesticides we want to observe are chlorpyrifos, dichlorodiphenyl trichloroethane or DDT, malathion and parathion. In a simple procedure, the first step is preparation. Extract the pesticides residues from the food samples using an appropriate solvent. Next, apply small spots of the extracts along with standard solutions of the pesticides on a TLC plate. The third step is place the TLC plate in the development chamber with a suitable solvent system. In this example, we are using sodium chloride. And the last one is the detection part. Visualize the spots under UV lights or by using a suitable staining reagent. In this slide, it shows an example of jotter of the experiment and also the result of TLC plate under UV lights. Last but not least, we have to calculate the retention factor to detect which food sample contains the following pesticides. For example, in apple sample, the spots travel is 4.5 cm divided with the solvent fine, which is 10 cm, so the retention factor is 0.45. After measure all the spots travel and calculating the retention factor, compare the result in a table. To interpret, apple extract contains chlorpyrifos and malathion, spinach extract contains DDT and parathion, tomato extract contains chlorpyrifos and parathion, and lastly rice extracts contains DDT and malathion.
So, we can conclude that application of thin layer chromatography for detection of pesticide in food has proven to be an effective and valuable method. Thin layer chromatography remains a valuable tool in the arsenal of analytical techniques for ensuring food safety. It is of use, affordability and ability to provide rapid results make it a preferred method for preliminary screening of pesticide residues. Continued advancements in TLC methodology and detection capabilities are expected to further enhance its effectiveness and reliability, contributing to safer food supplies and better public health outcomes.
Welcome to my vlog. Don't forget to subscribe.